Hi, this video is about how to measure electrical behavior in physics. Now in physics, and in science in general, the way that we make sense of the world is by measuring things. If we want to know what's going on, it helps to put a number with it. And so in the 19th century, scientists wanted to show that electrical behaviors and measurements could all be expressed in units that derived from pre-existing units of length, mass, and time. And back in this time, the scientists often use centimeters, grams, and seconds. This is the old CGS system. We use, instead of centimeters and grams, we use meters and kilograms in today's standard units of measurement. But in the 19th century, the understanding of electricity didn't have anything to do with atoms because our modern understanding of atoms just didn't exist yet. We didn't know about protons and electrons and neutrons, that kind of stuff in the 19th century. So really we're looking at electrical behaviors like rubbing a balloon against your hair and then seeing it attract a piece of paper, right? Or you also had simple electrical circuits at this time that would light up light bulbs and things like that. So we're trying to figure out how to measure that. So how do you measure it? Like what do you turn to? And so the kind of agreed upon consensus that formed was, let's say you took two wires like this and you passed the identical amounts of current through the wires, so electricity flowing through the wires. And if you place these two wires parallel to each other and place them 1 centimeter apart, going back to our centimeters, and you took a 1 centimeter section of that wire and measured the force that exerted, from one wire to the other, if that force was equal to 2 grams times centimeter per second squared, which is a unit of force, also known as a dyne back then, if that equaled 2 dynes of force, then that amount of current, they said, was equal to 1 BO. And this is a French name, so that's why it's pronounced kind of funny. But the amount of current needed for all of this to happen here was defined as 1 BO. So a BO of current was enough to give you 2 dynes of force between these two wires. Now that's really old units, we don't use that anymore, but our current usage of units comes from this because as scientists moved to the meters and kilograms units, they developed a new unit for current called the ampere, or amp, which should sound familiar, and this was 1/10 of a BO. So this is a 1 BO over here, you divide it by 10, you get an ampere, or an amp. So this is where we get the unit of amp from. And from this unit, we can also derive a measurement of electrical charge. So for this part, imagine you have a thick wire, cylindrical wire here, carrying electricity through it, and you take a little cross section or slice of it right here. That's what this is supposed to represent. So if you had a current of 1 ampere or 1 amp flowing through, then the amount of electricity or electric charges that pass through this cross section in 1 second is going to be called 1 coulomb of charge. That's the amount of electrical charge that passes through there in 1 second. So this is Coulomb. It's named after Charles Coulomb. Ampere is named after Ampere. So all these come from different scientists who made contributions to electricity. There's a lot of them. And so 1 coulomb of charge, it happens to pass by in 1 second for a current of 1 ampere. That's a lot of words here to keep track of, but 1 ampere is equal to 1 coulomb per second passing by. So in summary, the units that we're dealing with here so far for electrical behaviors, we have current and charge. Current is how quickly the charge passes. So current we measure in amperes or amps. We abbreviate ampere with a capital A, and we've already talked about the definition. And then charge is a coulomb. We use that word or that name for measuring how much electrical charge is present, capital C, and that's the amount of charge that passes through a cross section of wire in 1 second when the current is 1 ampere. And while today's definitions are modified slightly based on our more modern understanding of the speed of light and different things like that. They still are basically derived from these original definitions back in the 19th century. So that's all I've got for you in this video. Remember, shortcuts make long delays.